Hello everyone, in this video we're going to talk about a linear equation word problem. At 1:30 p.m. Megan starts working at a rate 4 miles per hour along a straight line path. 10 minutes later, Patrick starts walking in the opposite direction at a rate 3 miles per hour along the same line path. If both carry a walkie-talkie whose maximum range is 0.9 miles, at what time will their connection be lost? Okay, so basically what it's saying is how much time will it take until they reach their distance reaches 0.9 miles, right? So they're walking in opposite direction. So let's draw a picture to see how this will point out. So suppose that this is their distance basically. Okay, and we will think of this distance as the walkie-talkie maximum range. Okay, so we'll think of this as 0.9 miles. Okay, now based on the fact that Megan walks faster and also she will spend more time walking, they'll probably start somewhere here, right? I'm not going to be exact on it, but that's probably where they're going to start. So suppose that Megan will walk that way and Patrick will walk this way. Okay, so they're walking in opposite directions, and Patrick also spends less time walking, right? Because he starts walking 10 minutes after Megan starts walking, right? So he will spend less time walking, but he will walk slower, obviously, because his rate will be 3 miles per hour, right? But in any case, now you see what this problem will typically mean, and now we can use the fact that rate times time is equal to distance. Okay, in other words, rate multiplied by the time is equal to distance. So let's create a table. Okay, so we're going to create a table involving Megan and Patrick. Okay, and so we label the rows, and now we're going to label the columns as rate, time, and distance. Okay. So now, for Megan, the rate will be 4 miles per hour. Okay. The time that she will walk is t hours. We don't know the time. It's just going to be t hours. Now the distance will be rate times the multiplied by the time, so it's going to be 4t, right? Now 4t hours, right? Because miles per hour multiplied by the hours cancels out the hours, and you're left with simply miles. Okay, so 4t miles, because that's the distance. Now the Patrick the rate will be 3 miles per hour. Now we have to be careful how we label the time. It says that 10 minutes later Patrick starts walking. So he will walk 10 minutes less than Megan, right? And Megan will walk t hours, so that means now how do you convert? You're going to have to subtract from t, right? But you're going to have to subtract hours and not minutes, because here he walks 10 minutes less than Megan. Now 10 minutes converted to minutes will be 10 minutes converted to hours will be 10 multiplied by 1 over 60, right? 1 hour over 60 minutes. So let me write it here. 10 minutes converted to hours will be 1 hour over 60 minutes. So that will be 1 over 6, right? 10 over 60, which is 1 over 6 hours. So that's the amount of time that he will walk less. okay, by this amount of time. So he will walk t minus 1/6 hours. Okay, he will walk 1/6 hours less than Megan, so he will walk t minus 1/6 hours. So now the distance will be again multiplying the rate and time. So it's going to be 3 multiplied by t minus 1/6, and again it's going to be miles, right? So now what do we have to do? Based on my initial picture here, where I showed you that this is the starting point, Megan covers her part of the 0.9 miles. She covers the part, her distance is a part of the distance, part of the maximum range of the walkie-talkie. And Patrick's distance is the missing part, is the remaining part of the 0.9 miles, which is the maximum range of the walkie-talkie, right? So it means that we will have to add these distances, their individual distances, to get 0.9 miles. So we're going to have 4t plus 3t minus 1/6 is equal to 0.9, right? The maximum range of the walkie-talkie. Okay, because we have to solve for t in order to find the time when their connection will be lost. And it means they will have reached the maximum range of the walkie-talkie. So now solving for t, we get 4t plus 3t minus 3 times 1/6. So that's 1/2, right? If we simplify it, reduce it, is going to be equal to 0.9. So now, like terms, 7t minus 1/2 is equal to 0.9. So it means that 7t is equal to 0.9 plus 1/2, that's 1.4, right? Because 1/2 is 0.5, so 0.9 plus 0.5 is 1.4. Dividing both sides by 7, t is equal to 0.2. Okay, now be careful, it says 0.2 hours, right? So we don't know what this is, we have to convert it. We have to convert. So let's convert 0.2 hours times 60 minutes per hour. So that's going to give us 60 times 0.2 is going to be 12.0 minutes. Now this is the time after 1:30 p.m., right? Because they start, Megan starts walking at 1:30 p.m. and that's when the countdown begins. So we have to add the 12 minutes to 1:30 p.m. in order to estimate the exact time at which the maximum range of the walkie-talkie will be reached. So that's going to be 1:30 p.m. plus 12 minutes. So that's going to be precisely 1:42 p.m. This is your answer to this problem, 1:42 p.m. Thanks for watching. Please subscribe, and I'll see you in my next video.